Did you know that just 2 weeks after NASA showed us the first pictures from the James Webb Observatory, scientists got some surprising news that could shake up everything we thought we knew about the universe? The telescope found galaxies in the early universe that we didn't expect, throwing a curveball at our current understanding of how the cosmos evolved. This discovery is making astronomers rethink the widely accepted Big Bang model, making things even more interesting in the world of cosmology. Why did they come up with this so long after the first time they saw this evidence? Scientists using the James Webb Space Telescope found surprising things about the early universe. In a recent study of 88 faraway galaxies, scientists were amazed to find stars and galaxies appearing shortly after the Big Bang. Julian Munoz from the University of Texas was puzzled by this early formation. Some think the fast expansion of space in the early universe sped up galaxy and star development. But why this expansion happened so quickly is still unknown. A new idea suggests the universe's expansion could be due to merging with other universes. This theory, from a December 2023 paper, aligns better with observations than the traditional model. Jan Ambjørn, a scientist at Copenhagen University, found something interesting. He thinks the universe is expanding faster because of dark energy, and this might happen when smaller universes join together. This idea could make more sense than what scientists usually think. Now let's look at this cool research and see how other universes might have started. We'll also check how these universes coming together could help explain a mystery seen by the Webb telescope. Even with strong telescopes, we can't see everything in space. The universe is getting bigger, making galaxies move away from us super fast, even faster than light. When we talk about our universe, we mean the part we can see, about 93 billion light-years wide. It's like a ball containing everything we can see from Earth or space telescopes. The light from these things has reached us since the universe started growing. At first, scientists thought there might be 2 trillion galaxies, but new data in 2021 reduced that to a few hundred billion. Assuming the universe is the same in all directions, the distance to the edge of what we can see is about the same everywhere. There is a circle like a round one that contains us, and everyone in the universe has a space which we can see, but sometimes it may be different than ours. The sky, which is what we can see from the outside, is only home to a few galaxies, but there are more of them, and scientists believe that the universe may be endless. But the big question is, the starting point of all this? What is it? It is estimated that about 13.8 billion years ago, all the great expanse of space was compressed into a single speck, which was termed the singularity. This was not just a random point in space. It was incredibly difficult to imagine such an unthinkable condition for our universe. It was the ultimate container where all the visible items of the universe were packed into this tiny spot. Here's your state like a huge empty area, which is endless. Imagine the beginning of our universe as a kind of infinite void that was growing bigger and bigger. This expansion happened so fast, literally in a blink of an eye, extremely short. A billionth of a trillionth of a second. The universe became observable to us 10 orders of magnitude larger, or a factor of 100 million billion in all directions. The scientists have named this rapid extension the cosmic inflation. When the human race moved to distant parts of the solar system leaving the Earth, some disturbances in the quantum field happened. These disorganizations actually gave birth to matter, and that's why we see the stuff we see in the universe. It appears that matter has just suddenly popped out of emptiness at a certain moment, and this event is well known as the Big Bang. The overwhelming number of scientists hold the view that the universe developed in all matter at the same time, the so-called cosmic expansion or inflation. Nevertheless, the key is in the comprehension, how this rapid expansion stopped, and it has become a slower, ongoing expansion. On one hand, however, some rival theories imply that the universe's fast expansion has occurred in different parts of the universe. Already in the 1980s, Paul Steinhardt and Alexander Vilenkin suggested an outstanding idea. They assumed that the exponential growth of cosmic inflation was limited to the part of the universe that we can see and might be going on infinitely in other parts that are out of our view. Just picture the space growing infinitely, and when that happens, you come to something like 10 to the power of 72 or even more, and it stops at a certain point. In this situation, this area becomes a bubble universe, which shows either our reality or any other random universe reality. And at the same time, space could continue to greatly expand in other parts of the universe. It takes about 10.32 seconds later. The expansion will be stopped in the new universe. Then, a new bubble universe is created. Now we have two, but we do not know how these two universes are related or if there is a connection at all. However, the distance in between these two realities is dilated as the time goes by. Coming to the final stage of this universe inflation, the bubble universes arise as part of the deflating process. These bubbles become even more distant from each other, and the space between them expands at an exponential rate. Steinhardt and Comperience suggested that if the decay of the inflation field goes slower than the universe's expansion, the inflation could continue indefinitely and produce many more bubble universes. This concept, which is often called the eternal inflation theory, is a widespread one. The everlasting inflation theory is one of the most complex concepts in the universe. The multiverse theory, in its essence, states that the universe we consider to be real is only a small part of a vast space which is constantly expanding in an exponential manner. In this model, the inflaton field is responsible for cosmic inflation. When a bubble shifts from the inflationary to the non-inflationary state, a lot of energy is produced within the bubble. This mass energy contracts, forming the matter in the bubble, which expands. Scientists, on the other hand, claim that the universe we know is one of the baby universes, and there is a fascinating chance that any two of them can collide. This notion lends credence to many universes and the possibility of encounters among them. In a recent study, scientists revealed a captivating finding. In the early stages of our universe, it is possible that we came into contact with another universe that is located close by. Meanwhile, our universe is accelerating at a fast rate, but not all the scientists are in agreement about the fact that dark energy is the primary factor. Others suggest that our universe is possibly merging with and conquering smaller baby universes. The author of the paper suggests that the super-fast expansion of our universe within the short epoch might be because of a possible collision with a bigger universe. That is, we are merging into a parent universe. If this theory is correct, then their explanation could be the key to our understanding of the Webb telescope's discovery of large and very luminous early galaxies. Scientists suggest these early galaxies might be of the rapid formation type due to the collisions of our universe with other baby universes. This research provides evidence that it is not fiction anymore, that there are other universes beyond the one that we live in. With optimism, we shall continue to have a glimpse on these multiverse theories in future. The most amazing discovery made by the James Webb Space Telescope is a black hole that is redefining the theory of the universe we believe in. Mikio Kaku, an outstanding scientist, is very captivated by this finding. He believes we could be possibly observing the largest black holes, and thus, they could help us know more about how the universe operates. Such a finding is a milestone because we learn how the universe was created in a way that was previously unknown to us. The black holes and distant objects are among the objects that are difficult to observe in space due to their vastness. There is a high possibility that we are overlooking the oldest galaxies and black holes because we can't see them due to the more sophisticated technology. Nowadays, gravity lensing is the goal of scientists. This impact will bring us the sight of even more ancient and even larger black holes so that we will have a full picture of the world in the early period. Gravitational lensing was discovered by chance when astronomers observed unusual distortions in pictures that appeared. Gravitational lensing is due to very heavy objects such as galaxies or black holes. The gravity of the rapid approaching objects, very heavy ones, in the background is amplified, and the small and distant ones are magnified. This minute yet overwhelming astronomical coincidence has proved to be a great help to the astronomers in the recent past to discover the faraway galaxies and exoplanets that would have been invisible otherwise. Scientists are now following the lead provided by this discovery and are planning to use their knowledge to look further and further back in time in order to reveal the details of the very early universe. A picture of some galaxies that are so old that they fault the accepted understanding has made the astronomers and cosmologists tremble with fear. To the disbelief of the researchers, it has been discovered that in at least one of these galaxies there is a gigantic black hole at the center of the universe that they have called universe breaker. This discovery is able to change our views and understanding of the entire universe. The idea that the new telescope might be able to overturn firm existing knowledge might have seemed ridiculously fantastic. While physics still deals with the most complex puzzles, the study of these mysteries has led to significant discoveries and progress. Shortly after the first images of the telescope were released, people were overwhelmed with hope. Either the answers to some riddles would be provided, or some well-known theories, such as the Big Bang, would be confirmed. NASA's presentation of a photo showing the stars and galaxies of different ages, the youngest ones being purple and white, the older ones reddish and darker, kick-started a feverish attempt of deciphering the universe. The whole world's research teams utilized cutting-edge technologies to study the information each dot of light in the picture contained. Research has made use of computer technologies which have enabled the scientists to establish its age, the elements reflecting the light, the galaxy's velocity, and the estimated number of stars. James Webb Space Telescope, the technological marvel, sends us to the time of the Big Bang, 500 million years ago. This image is a glimpse of this time. The findings were made public after that black holes of a mass 10 million times that of our Sun and other ancient galaxies were discovered. The puzzling issue is what gives rise to a supermassive object at the dawn of the universe when everything is supposed to be unformed. The finding of a supermassive black hole at that time shortly after the cosmic Big Bang makes the current understanding of the formation of galaxies completely insufficient. In line with the standard Big Bang theory, the only entities which are supposed to be there are incipient stars and star clusters, which are the very early forms. However, the observation reveals 6 galaxies characterized by their massiveness, brightness, and abundance of stars, all potentially hosting supermassive black holes at their centers. In early 2023, scientists with 2 surprises about black holes revealed themselves. The results showed evidence that something very huge and still unknown is getting sucked into the black hole at the center of the universe we are living in. The second finding implied that there were some advanced alien civilizations which were using black holes as ultra-powerful quantum computers. The disclosures occurred in the same period, leading to the development of the hypothesis of any possible link between them. Astronomers consider its origin, assuming it's a remnant of a star from their journey. Some believe that the most advanced civilizations that use black holes are invisible because they have already completely transformed into energy in order to go near black holes without being torn apart. In plain words, the researchers discovered an amazing huge object in the vicinity of our galaxy's black hole. Some expected it to be a spaceship from aliens or a supercomputer being operated using the black hole, but they found it to be a huge cloud of dust and gas. Meanwhile, this cloud called X7 is rapidly moving towards the black hole, and by 2036, it will get so close to it that it will probably get devoured, producing a very bright spot. It is hypothesized that black holes could be used by high-tech civilizations, and that they would be unseeable because their energy could have transformed them into pure energy. Long before the first discovery of a black hole by the British astronomer John Michell in 1783, based on the theory of gravity proposed by Albert Einstein, these cosmic giants have been a source of fascination for scientists, as they are places where the laws of physics can be bent and even defied. The James Webb Space Telescope did not only discover the earliest black hole, but also has completely transformed our views on them. This evidence showed that the black holes were more common and massive than thought before in the universe's early epoch. It was believed in the past that black holes were formed as a result of stellar death, which caused the collapse of stars at the end of their life cycle, and as a consequence, a point in space where gravitational forces were becoming infinite. However, the Webb telescope studies revealed that these galaxies were older than the Big Bang, and therefore they were formed before the Big Bang. This revelation prompts two possibilities. Either our universe is older than we ever realized, or black holes do not form in the process that our models predict. The recently discovered 6 galaxies by James Webb Space Telescope is an undeniable evidence of the universe's unique range and complexity. As a result of this, a revival in our study about the nature of these celestial monsters has occurred. Even though the universe is flooded with colors and the cosmos phenomena provides us with the opportunity to go beyond the limit of our understanding, black holes and other cosmic phenomena lead us beyond the limits of our understanding. Monsters are the black holes, which are built out of the dead stars in millions or billions of years, that are a challenge to the current model of the universe's development. This means the re-examination of existing theories of black holes, star formation, and galaxy development. The other theories as well suppose that there were first stars in the universe which were large, bright, and very short-lived, and the black holes with high mass might have been created by them, and as a consequence, the formation of stars in the neighborhood was affected, which ultimately led to the appearance of turbo-galaxies. The tremendous impacts of supermassive black holes in the nucleus of the galaxy raise questions regarding the development of galaxies, as these objects yield a gravitational force that can both stimulate and inhibit star formation. Many theories put forward different processes that lead to the growth of black holes, which may include the merging of numerous black holes in high-density early universe regions, or the direct formation that does not need the stellar evolution to take place. What lies at the core of the question might be fathomed with more thorough investigation and the progress in our methodology of observation. Well, now you ended up here. Click on the video on your screen for another space adventure.